Everyone, thanks for being here for this presentation. I'm Dr. Marcia Hawk, and this presentation explores the importance of auditing AI ecosystems. Quick setup before we dive in. When people say AI, they usually mean one thing, whatever has been in the news that week. But inside any real organization, you're not dealing with just one AI. You may be dealing with several different AI systems, each making decisions that affect real people. So over the next few minutes, I want to walk you through those 7 categories. For each one, we will look at what it actually does, where you've probably already seen it, and what can go wrong, and most importantly, what a real audit of an AI system needs to cover. The goal isn't to make anyone afraid of AI. The goal is to give you a clear mental map, because once you can name the type of AI in front of you, you can actually start asking the right questions about it. So let's get into it. So before we get into the 7 different types of AI system, I want to give you the lens we're using. Every AI category we look at gets broken down the same 5 ways. What it is in plain English, a real example you've probably encountered. Why companies adopt AI systems in the first place, because nothing here exists for no reason. There's always a business case. Then the risk, and finally, why auditing actually matters. I'm doing it this way on purpose because the temptation is when you're talking about AIs to get people get really technical or they get philosophical and both miss the point. What governance teams, executive, and regulators all need is the same thing, a way to compare radically different systems on the same axes. A fraud detector and a resume screener look nothing alike, but once you ask the same 5 questions about each one, you can suddenly see which one is riskier, which one needs more oversight, and where your gaps are. So that's the frame. Keep it in your head as we go through these 7 different categories. So the first AI system we'll talk about is generative AI. This is a category that creates new content from a prompt. Text, images, code, audio, video. The classic example is a marketing copy generator. Someone types in, "Give me 5 Instagram captions for a spring sale," and the AI just produces them. Why do companies love it? Because it speeds up the process. Work that used to take a copywriter a half a day can happen in 30 seconds. But, and this is a big but, the risks are real. The model can hallucinate. It can produce something that is factually wrong, but sounds completely confident. It can output something biased or toxic without anyone noticing until it's already live. And there is a whole copyright question hanging over the training data. So when you audit a generative AI system, you're not just checking, does it work? You're testing factual accuracy. You're running bias evaluation. You're checking the prompt safeguard. What guardrails stop someone from making it say something that is harmful? You're verifying that a human actually reviews the output before it goes out, and you're being transparent with users that they're seeing AI-made content. The short answer, of course, speed without oversight is just a faster way to make bigger mistakes. Number 2 is prediction models. These are the systems that look at history and try to tell you what's coming. 3 quick examples on this slide: a student performance predictor that flags which kids might struggle this semester, an energy demand forecaster that tells the utility how much power to generate tomorrow, and a customer churn model that tells your sales team which accounts are about to leave. Useful, right? Hugely useful. Predictions let organization plan instead of react. The catch is, though, you've heard this one before, is that these models are only as good as the data they're trained on. If historical data reflects a biased world, the prediction reflects a biased future. A student risk model trained on a district where certain neighborhoods got fewer resources will quietly predict that kids from those neighborhoods will struggle, not because anything about them, but because of what happened to the people before them. Because remember, you're using historical data that does not represent the current student. So auditing here is really about fairness, accuracy over time, and what we call drift monitoring, because a model that worked beautifully last year might be quietly degrading right now. You also need explainability. If a model is telling a guidance counselor that a kid is at risk, that counselor deserves to know why. The shorthand, prediction is powerful. The past is not always the future you want to create. Each type of AI system is classification. Sounds dry, right? It's actually one of the most consequential categories. A classification model puts things into buckets, yes or no, pass or fail, match or no match. Look at the examples. A resume screening tool decides which CVs a recruiter sees. Voice biometrics decide when the person on the phone is really you. And a radiology classifier looks at an x-ray and decides whether there is a tumor. These are not small decisions. These are gatekeeping decisions. So what can go wrong? Discrimination, first and foremost. If the resume screener was trained on past hires and your past hires were skewed, it will quietly perpetuate that. False positives matter. Fraud classifier that locks the wrong person out of their bank account ruins their day and maybe even their vacation. False negatives matter even more. A radiology tool that misses a tumor can be a tragedy. And anytime you're classifying people, you're touching privacy. Auditing here is about fairness metrics broken down by demographics. It is about stress testing. Does the model work as well for one group as it does for another? It is about confidence threshold, and it's also about making sure that when the model is uncertain, a human gets involved. After all, if the system is going to put people into categories, somebody had better be checking which people end up in which category and why. The number 4 type of AI system is computer vision and biometric AI. This is AI that sees. Cameras at an office entrance that unlocks the door when they recognize you. A bank app that confirms it's really you by scanning your face. Surveillance systems that monitor entire facilities. Computer vision is everywhere now, and most people don't even realize how often they're being processed by one of these systems on any given day. The business case is obvious: convenience, security, and speed. But this category has the heaviest civil liberties footprint of any we'll discuss today. Facial recognition systems have a well-documented history of being less accurate on darker skin tones, on women, on younger and older faces. That is not theoretical. Wrongful arrests have happened because of it. Beyond accuracy, there is a question of consent. Did the people being scanned ever actually agree to it? So the audit focus here is heavy. You test demographic accuracy explicitly across skin tone, ages, and genders. You verify consent governance. Who agreed to what, and is it documented? You check privacy protections, including how long biometric data is stored, and you make sure that the system complies with the patchwork of biometric laws that varies by state and country. If a system is going to recognize the human face, it had better be fair to every human face. Type 5 AI system is natural language processing, also known as NLP. It is AI that reads, interprets, and responds in human language. Think of an NLP triage assistant at a hospital that reads patients' intake forms and helps prioritize who gets seen first. Or an agentic research copilot that goes off, reads 20 documents, and comes back with a summary. Or the customer support chat agent you talked to last week without realizing it wasn't even a person. The appeal of NLP is that language is how humans communicate, and AI that can handle language can sit at the front door of just about any process. The risk is that language is also incredibly easy to get wrong. Because context matters, sarcasm matters. The same sentence can mean two different things depending on who said it and how it's said. NLP models miss context constantly, and when one is making recommendation, especially in a clinical or a financial setting, those misses can be very harmful. Add in the hallucination problem and the temptation to fully automate, and you can see how this gets dangerous really fast. Auditing means testing responses reliably across realistic input. It means running safety evaluation on the weird edge cases people will actually throw at NLP. It means putting hallucination controls in place that answers the question, What does the system do when it's not sure? And critically, it means having a clear escalation path. When an NLP system is out of depth, a human needs to be the next stop, not the next user. The number six type of AI system is actually decision support. Pay close attention to this one because it is a category that quietly causes the most controversy. Decision support AI doesn't make the final call, at least not officially. It just sits next to a human and says, here's what I recommend. For example, a loan officer sees a dashboard with the AI suggested decision. A hiring manager sees a candidate score. And a doctor sees a triage priority. Why do companies love decision support? Because it accelerates expert work and creates a paper trail. Why is it risky? Because of something called automation bias. When a person is busy and the AI is confident, the human tends to just go along with what the AI suggests. The human in the loop exists on paper, but in practice, they're rubber stamping. That's how AI that was never supposed to make decisions ends up making them at scale without anyone really noticing. So auditing here is usually demanding. You need explainability for every single recommendation. You need real human in the loop controls, not just theatrical ones, meaning the reviewer actually has time, training, and the authority to push back. You need adverse impact testing across protected groups. And you need workflows that document when the human agreed and when the human overrode. This is how you get to retrain your models. If a human is officially making a call, but the AI is unofficially making it, that's not decision support. That's decision laundering. The audit has to be able to tell the difference. So the last category we will discuss is detection and security AI. These are the systems that watch for threats, anomalies, or anything suspicious. Fraud detection on your credit card, intrusion detection on a corporate network, or insider risk monitoring inside an enterprise. This category is unique because it almost always is running silently in the background. You only hear about it when it triggers an event, either correctly or embarrassingly wrong. The trade-offs here are sharper than anywhere else we have looked. Set the model too sensitive and you drown your analysts in false alert. Alert fatigue is a real documented security problem. If you set it too lenient and the actual attacker slips through, then that's also a problem. And unlike most of the AIs we have discussed, this one has active adversaries, someone on the other side deliberately trying to fool the model. Add in the privacy dimension. These systems often monitor employees on customer behavior at a very granular level, and you've got a category that needs serious oversight. The audit focus is precision and recall. What percentage of alerts were real and what percentage of real threats did we actually catch? Incident validation workflows? Do humans review and confirm? Adversarial testing, can someone trick the model on purpose? And monitoring effectiveness over time, because the threat landscape shifts constantly. A detection system you can't measure is just a vibe. We actually need numbers. Let's slow down here. Let the slide breathe. Here's the one thing I want you to take away from these 7 categories we've discussed. AI systems are no longer tools that humans use. They're becoming participants in human decisions. They sit inside the moment a doctor decides who gets seen first, a bank decides who gets a loan, a school decides who gets flagged for intervention, a company decides who gets hired. That changes what we owe these systems and what they owe us. For a long time, trust in technology was something we assumed by default. If the software shipped, it must work. If the dashboard says so, it must be true. We cannot operate that way anymore. When AI is making or shaping decisions that change people's lives, trust has to be earned and re-earned continuously. It can't be assumed. It has to be audited. That's the pivot point of this whole conversation. And this is why we built Fairmind Auditor for auditing AI systems. So this is where we land. The Fairmind Auditor is a governance layer for everything that we just walked through. The 7 pillars on the right Map directly to the question that came up in each AI category. AI governance, who owns each model and what's a policy, risk classification, tiering systems by how much harm they could cause, so you spend oversight where it really matters. Bias assessment, running the demographic tests at scale instead of one-off when something goes wrong. Compliance tracking, keeping pace with regulations that, frankly, are changing faster than most organizations can keep up. The human oversight, making sure escalation paths actually exist and actually work. Audit readiness, so that when a regulator or a board or customer asks, show me, you can show them, not scramble for it. An ethical AI operation, the day-to-day practices that turn all of this from one-time exercise into how your organization works. The promise is simple. It is line on the slide. Trust, audited. If you want to see how this works for the specific systems you're running, that's a conversation we'd love to have next. Thank you for watching.